So here are the solutions of the little exercise sheet I gave you about formal logic. For question 1, it's about the negation of statements. Question 1, you have to try to do the exercise before watching this video, of course. And you can pause the video anytime when you don't, when you think you can maybe spend a little more time on the next question, but really try to find it by yourself before watching the solution. So your statement is the number n is even. The negation of this is the number n is not even or the number n is odd. Second statement, x is greater or equal to 0. The negation of this is x is strictly inferior, to 0. Okay, it doesn't work. Because the first statement was x is greater than 0 or equal to it. And the negation of this is the other numbers, and the other numbers are here. Inferior to 0, strictly inferior to 0. The statement was for all n. So I'm going to, for the next one, I'm going to write P. P is for all. For any whole number n, un, which is the term of sequence, is strictly superior to 1, which means you have 1 here and all the terms of your sequence are above this, right? Probably many of you wrote this, not P is for n in, I said n, un is maybe inferior to 1 or inferior and equal, or I don't know. But this is not true, even if you wrote that, because this is not true. In the common language, when you say like, all the students here play football, when are you wrong? How can someone prove you wrong? Someone can prove you wrong by showing you one student who doesn't play football, right? So the negation of all of them are above 1 is there exists one of them which is not above 1. So not P is there exists a rank or an index for which the term un is not above 1. It's on 1 or below. So this is a very important mistake. If you made it, write it down and you will have to analyze it. The last one was your statement is there exists an x, a real number x, such that f of x is greater than 2, which means if you have a function f, one of the images of the real numbers by this function is above 2. There exists 1. And the negation of this is none of them is above 2. Like the statement was there exists 1 which is above 2, and the negation of that is none of them is above 2, which means all of them are below, which means for all real numbers x, the image by f is below 2. So it looks simple, but sometimes you will make mistakes with this. This is very important. How to write the negation of a statement is very very important because a lot of mathematical proofs are based on a negation like that. Question 2 was about the conjunction. So you had the statement P, the number n is even, statement Q, the number n is a multiple of 5. Or you can write the number n is even and is a multiple of 5. It's very simple, which means the number n is a multiple of 10. If you wrote that, of course, you're right. Second question was x is between, so you have a range here. So I'll make a drawing to show you how it works. 7, 12, and infinity here. First statement was x is between 3 and 12. It's a range, so it's not whole numbers, it's real numbers. So your x is here. Second statement, your x is between 7 and infinity. Here, it's about a conjunction, so it's an and. You want x to be in the red and in the blue, which means this. So your P and Q would be x is between 7 included because 7 is blue and red, and 12, and you don't take 12 because 12 is blue, but 12 is not red. And next one, for all n in the set of the whole numbers, un is greater than 1. For all n the set of the whole numbers, un is smaller than 3. And the conjunction will be for any, oh, excuse me, it doesn't work. Whole number n, un is between 1 and 3. Last statement of the question 2, there exists x such that f of x is above 2. So it means that here you have 2, here you have 3. So the first statement is there exists a value for which its image is smaller than 2. And the second is all of them, all of the values are above 3. So probably some of you didn't answer. I didn't ask you if it was right, if it was false, or if it was true. The question was, write the conjunction. The conjunction is there exists an x in the set of the real number such that f of x is smaller than 2, and that's a conjunction. And for all x in R, f of x is greater than 3. And that's, I told you, write it. Okay, it's false. It's called a contradiction. It's always false. It's okay, but you can write false things as long as you know it's false. It doesn't mean that you can't write it down. You can write it down, right? It's false. Okay, it's false. There are many mathematical proofs that are based on the fact that something is false. When you use Pythagoras theorem, if you show that your equality is false, it means that the triangle is not a right angle triangle. And well, you proved something. It is not a right angle. You have an information, a new information. So dare to write something that is false. If you know it, just write false, and it's okay. some proofs in math are based on the fact that you find a contradiction at the end. It's called a proof by contradiction. So you need to accept writing false things as long as you know that they are false, right? You write contradiction and it's okay. So they exist. It's like I can write that it's been snowing in Toulouse for all during all the summer. It's false, but I can write it down, right? Question 3. It's about or. It's about the disjunction. So I'm not going to write it down. The number n is even, and q is the number n is odd. So the disjunction is the number n is even or the number n is odd. It's true if n is a whole number. So that would be a tautology. Second one, I'm going to make a drawing like last time. So your statement P is x is between 3 and 12. Your statement Q is x is between 7 and infinity. And so 3, 7, 12, infinity. Let's get there. So between 3 and 12, and I don't take 12. Between 7 and infinity, and I don't take infinity. And the word is or, right? It's a disjunction. It has to be in the red or in the blue or both, remember. So your disjunction would be x is in the red or in the blue or both, which is in this range. Next question. X is a real number and x is positive. And the other is x is a real number and x is negative. So, which is equivalent to x is a real number, because if it's a real number, it's either positive or negative. And the last one would be x squared is equal to 9 or x squared is equal to 16. It's okay, I didn't ask you to solve this. Question 4. The question 4 is slightly more difficult. Well, it's just to have you build a truth table at least once. So I've been doing that in my videos, but it's good that you do it for yourself at least once, right? And it's not the simplest one. It's quite long. It's not difficult. It's just long, right? It's only zeros and ones. You don't have anything to compute. So maybe I'll erase everything if you don't mind, because I will need more room. I think the table is big. If I want to write down all the steps, it's going to be a big table. Okay. So for the first question, P, Q, and I will need P and Q. Then I will need not P, I will need not Q, I will need not P and not Q. And then I will need P and Q, or not P and not Q. Same thing as usual, 0, 0, 1, 1, 0, 1, 0, 1. P and Q is false everywhere except here. Not P is the negation of this. So where you have zeros here, you have ones here. Not Q is 1, 0, 1, 0. Not P and not Q is true only when you have both. And now you want this one or this one, which means one of the two must be true, at least one, maybe both. And that's exactly the same truth table as this one. This is just, what you notice, it's the same, because I told you the equivalence in what is when they is true when they are true at the same time or false at the same time. Here they are false at the same time, the equivalence is true. Here they are true at the same time, the equivalence is true. So if you want, it's not very simple, but if you want, you can write this like that because it has the same truth table, so it's equivalent.